A gaseous sample of a compound has a density of 0.977 grams per liter at 710.0 torr and 100 degrees Celsius. The first part of this question is going to ask us what is the molar mass, and then the second part says if this compound contains only nitrogen and hydrogen and it's 87.4% nitrogen by mass, what is its molecular formula? So this problem introduces density to us. So the question is, how do we go from something like PV equals nRT to density? Remember that density is going to be typically represented in grams per liter or some type of mass per volume. So let's take this ideal gas equation right here and rearrange it to say N over V is going to equal P divided by RT. Okay, here this N over V has units of moles per liter, but density is in grams per liter. So think about how we go, and for this expression right here, we have moles per liter. Think about how you would convert moles per liter over to grams. So in this case, we would have to multiply here by grams per mole. The moles cancel out, and this is going to give us grams per liter, which is a density unit. If we think about what we have and what we know that's in grams per liter, this is going to be our molar mass. So we need to multiply by the molar mass, which is sometimes abbreviated with this weird kind of cursive capital M type of a letter. So in each of these cases here, we're going to multiply the left and the right side of the equation here times the molar mass. So we have N over V times the molar mass is going to equal the pressure times the molar mass divided by RT. We showed over here when we take this N over V, which is in moles per liter, times the molar mass, this is going to give us units of grams per liter, which is our density. So our density is going to equal the pressure times the molar mass divided by RT. Okay, if we rearrange this particular equation, we're going to get the molar mass is going to be equal to the density times R times T divided by P. And this derivation gives us a formula that is very, very useful in solving a lot of these problems that we're going to come into contact with. Okay, so for this particular case, the first part of the question says, hey, what's the molar mass? So the molar mass can be represented in terms of the density, the temperature, and the pressure, if we know our gas constant. So our molar mass is going to be equal to the density, which is 0.977, that's represented in grams per liter, okay, times R, which is 0.0821 liter atmospheres per mole Kelvin, times the temperature, which is 100 degrees Celsius, which will be 373 Kelvin. Okay, if we divide this by our pressure, which is 710.0 torr, and we convert that over to atmospheres, so we have atmospheres divided by 760 torr, gives us units of atmosphere for the pressure, and that gives us a molar mass equal to 32.0 grams per mole. And that is the answer to part A of our problem. So after we calculate the molar mass, we can move on here to part B, which is if this compound contains only nitrogen and hydrogen and it's 87.4% nitrogen by mass, what is our molecular formula? So first we need to figure out what the empirical formula is, then find our factor and try to determine what our molecular formula ends up to be. So first we're going to assume a 100-gram sample. And if we assume a 100-gram sample, we know that 87.4% is going to be nitrogen. So this means that we're going to have 87.4 grams of nitrogen. If we multiply that by 1 mole of nitrogen is going to be 14.0 grams. That gives us 6.24 moles of nitrogen. If we know that our compound contains only nitrogen and hydrogen, that means the other 12.6%, or the other 12.6 grams, must be hydrogen. For every 1 mole of hydrogen, there's 1.01 grams. So this tells us that we have 12.48 moles of hydrogen. So we compare these two values, find the smallest one, and divide each of those by that. So we're going to divide each by 6.24. So that gives us 1 mole of nitrogen for every 2 moles of hydrogen. So our empirical formula is going to be NH2. And if we want to determine the empirical formula weight, we know that nitrogen is 14 grams per mole and hydrogen is 1 gram per mole. We have 2 hydrogens, so we multiply these together and add, and we get 16.0 grams per mole for our empirical formula weight. We're trying to determine the molecular formula. We know the molecular weight is 32.0 grams per mole. The empirical formula weight is 16.0 grams per mole, which gives us a factor of 2. So we have to take our NH2, multiply by 2, and that's going to give us a formula of N2H4. So this is going to be the molecular formula of our unknown, or of our gas that contains nitrogen and hydrogen. So if we recap here, we've derived a nice way for us to figure out molar mass if we're given a density. So we have that relationship here, that the molar mass is equal to the density times R times T divided by P. So we did that in the first half. Then we use what we already know in how to determine an empirical and a molecular formula to determine what exactly the identity of our gas is containing nitrogen and hydrogen. And that's what we did down here in the last part to solve for B.